We've been talking about nuclear fission, which is the splitting of a large nucleus into two smaller fragments, which releases a lot of energy, and we can use that energy to generate electricity. Now, the opposite to fission is fusion. And this is when two atomic nuclei, such as hydrogen, quite light, small nuclei, join together under conditions of high temperature, and high pressure. Now, this is quite hard to do, to join these two nuclei together. And when it happens, it's called nuclear fusion. And this is the process by which energy is released in stars. Now, remember that the atomic nucleus is a positively charged thing. For example, we've got an isotope of hydrogen here called deuterium. And deuterium has a proton and a neutron. So it's still hydrogen, it's just a slightly heavier version. And here we've got an isotope of hydrogen called tritium. And again, this has now got two neutrons with one proton. Same thing, it's same hydrogen, but it's a different, heavier version, an isotope. If you force them together, well, you've got to overcome the positive electrical repulsion, because both of these are positive and they're trying to repel each other. To do that, you need huge temperatures and huge pressures, but if you can achieve that, then they will fuse together and create helium, and a neutron in this case. Now, this is the kind of process which happens in the sun. And just to give you an idea of how much temperature and pressure you need in the sun, the temperature in the core is 15 million degrees Celsius. The pressure is 200 billion times the Earth's pressure, called 1 atmosphere is what we experience. So 200 billion, it'll squash you to a pulp. And the energy that this produces every second is equivalent to 100 hydrogen bombs being let off. That's a serious amount of energy. And just to give you an idea, 4 million tons of hydrogen, that is 4 million tons of deuterium and tritium, are used every second. This is energy on a large scale. You need a lot of energy to actually make this happen in the first place. Now, we're trying to get this process working on Earth, and we're making progress. It's just trying to maintain this reaction, this fusing. And to do that, you need a special container. In fact, you actually need a magnetic field, because if you use a normal container, it cools the hydrogen down too much and it won't fuse. So this is fusion, and just to give you a little animation of this process with deuterium and tritium, let's head on over to here. So here we are, two isotopes, tritium, deuterium. They're forced together, they fuse, and that creates helium, and in this case a neutron which escapes. So I hope that's been of some help, and I'll see you in the next flashcard.